So we're going to talk about area of a triangle. And it seems weird because you talked about the area of a triangle back when we were in, elementary school, which is 1/2 the base times the height. But what happens if you don't know the height? So there's a couple of other formulas. So if you end up with an SAS triangle, so you know a side and then the included angle, there's another formula. Area is equal to 1/2 AB, not cosine, I do this every time, sine of C, okay? Or any way you want to write this, 1/2 BC sine of A, or 1/2 AC sine of B. And I always go back to cosine when I do this because we've just finished the law of cosines. And that's the mistake that I make. So if you're given two sides and an angle, you can use that one. And if you're given three sides, you can use something called Heron's formula. Not important that you know that, but the formula requires a couple different pieces. The first is S. S is called the semi-perimeter. There we go. Okay, perimeter. So what you're going to do is add up the three sides. A plus B plus C, and you're going to divide that by 2. Okay, so it's half the perimeter. So that's where you start. So you've been given three sides. You add them up, divide by 2. And now the area is the square root of this whole thing. S times S minus A times S minus B times S minus C. And that's the formula. So you have two other ways that you can find the area of a formula, or an area of a triangle, without having to figure out what the height is. So this will work in any triangle. So we're going to do some examples. So here is example number 1. So we have this triangle. You can stop and write it down. It has vertices of H, K, and P, and then we've been given the sides of all three of them. So the fact that I was given all three of the sides means the only formula that I can use to solve this is S minus A, S minus B, S minus C. And remember that S is equal to A plus B plus C divided by 2. So I always use a calculator for all of this. So S is going to be 12.7 plus 14 plus 14, that whole thing divided by 2. So 12.7 plus 14 plus 14, divided by 2. So I got S is 2.4, let's say, or 20.4. 20.4. Okay, so now I need to do this part. And if you want to write it the whole thing, you can. I tend to do it because I don't want to mess up. And I, like I said, always use the calculator when I'm doing this. So 20.4. Now I need to do S minus 14, for example, or 12.7. It doesn't matter. So 20.4 minus 12.7. 7. Okay, so that's going to multiply by 7.7. 20.4 minus another side is 14. So that's going to be 6.4. And the other side, the third side, is still 14. So that's going to be a 6.4 as well. So you could write this whole thing out if you wanted to. So I could do second x squared. That gives me the square root. 20.4 times 7.7 times 6.4 times 6.4. All right, enter. And that gives me that area is equal to 80.2 centimeters squared. So it's just a matter of plugging into the two formulas. So you've got to remember this part and then this part, that S is the semi-perimeter. So that's how you do example number 1. Given 3 sides, plug it into the formula. If you didn't want to do all of this under the radical, we could have said 20.4 times 7.7 times 6.4 times 6.4, and then second and x squared to get that, and then second negative sign to get my answer, and I got the same thing. So let's try another example. So I'll give you a second to write this down, pause it for example number 2. So in this particular triangle, we were given an angle and then the two sides. So I can't use the Heron's formula unless I found this side, which I could do. I could use what I know, like law of cosines or law of sines, to find this side and then use Heron's formula. But I could also use the other formula that I just gave you, which is 1/2 AB sine of C. So in our case, we don't have A, B, and C, but we could rename them, right? I could say, well, this is going to be C because that's the equation needs an angle, C. So then this could be A, this could be B. So this can be side A, that could be side lowercase b. So then I just plug in 1/2 times 15 times 16. Order of these two don't matter, right? Sine of 131 degrees. So when I put this in the calculator, I just end up putting in here 0.5 times 15 times 16 sine 131. So I got 90.6. 90.6, and this is meters squared. So you just have to label your triangle according to what pieces you're going to plug into the equation potentially. So here's example 3. I didn't leave myself enough room on this paper to write below, so I think I'll write above it a little bit. So given that the area of a triangle is 45 centimeters, with the measure of angle S is 40, side T is 10, find side R. All right, so let's just draw a triangle. And we have sides S, T, and R, right? It doesn't really matter which direction they're in. I know that this angle is 40 degrees. I know that side T is 10, and I'm asked to solve for R. And I do know that the area is 45 centimeters squared. So what I would do is plug into my equation, A is equal to 1/2 AB sine of C. Because I don't have 3 sides, but I do have an angle, and then I know what the area is. So this is what I'm going to end up using. So again, I'm going to make S into C. So T can be B, let's say, and that way A would be R. So instead of plugging in and solving for area, I have the area. 45 is equal to 1/2 times R, which is what I'm solving for. B is 10 times sine of 40 degrees. So I'm going to do 1/2 times 5 sine 40 degrees. So 0.5 times 10 sine 40 degrees. So I got 45 is equal to 3.213938048R, right? Big long number. In my calculator, so I don't have to really worry about that whole big thing, I'm going to do 45 divided by, and then I'm going to hit second and then answer down here, because what that's doing is pulling that number in, and then I'm going to hit enter, because that's what I had to do here. I had to divide by 3.21 nonsense, right? So I ended up with 14 is equal to R. So the missing side on this equation or on this diagram is 14, because I delighted those two. So you can work backwards using this formula. The S formula, not so much. So here's another one. Given the area of a triangle is 35 centimeters squared, and S is 5, T is 15, what is the measure of angle R? Okay, so now I'm using the same equation. A is equal to 1/2 AB sine of C. I could rewrite that as 1/2 times S times T sine of R. So, area I know, 35 is equal to 0.5 times 5 times 15 sine of R. Okay, so I'm going to multiply all those together. 0.5 times 5 times 15 is 37.5 equals 35. So now I'm going to divide both sides by 37.5. So 35 divided by, I can also go up and grab that answer to put it there. So I got 0.93333 repeating. And remember that we're talking about sine of R, right? This is sine of R. So we're going to use the inverse function for this. So we're going to say that sine of my number, 0.933333333, inverse is equal to R. So second sine to get the -1, and then I'm going to grab that answer, press enter, and then press enter again. And I got that angle R is equal to, what did I pick? Let's say 69 degrees. So if you're given the area, you can work backwards. So you just have to recognize what you're plugging into which equation will work for what you've been provided.